Good morning, everyone. I would like to introduce the speaker of today. That is Jason Mayes. He's a Google Web AI lead. I'm sure he's going to have more interesting short story to share with you. But let me start with a very interesting number that was put in the description of the session today. That is the Web AI libraries and model crossed over 1 billion downloads in the last 2 years alone. I'm sure the number is exciting on itself. But the information that we're going to share in the session today is going to be even more exciting.
Hello, everyone. I'm Jason Mayes, Web AI lead at Google, as you just heard. But today I come to share a story as a fellow developer about why you should start investigating machine learning on the client side in JavaScript to gain superpowers in your next web application. First, let's start by formally defining what I mean by Web AI, which is a term I coined back in 2022 to stand out versus cloud-based AI systems, which were popular back then. Web AI is the art of using machine learning models client-side in a web browser, running on your own device's processor, graphics card, or even NPU, using JavaScript and surrounding web technologies like WebAssembly, WebGPU, or emerging standards like WebNN for acceleration. And in some cases, the model can even be built into the browser itself and exposed to JavaScript developers via emerging APIs for common tasks like prompting, summarization, and translation. Now, all of this is different from cloud AI, whereby in that case, the model would execute on the server side and be accessed via some sort of API instead, which means you need an active internet connection to talk to the cloud API at all times to provide those advanced capabilities. Now then, as web developers and designers, we have the privilege of working across industries when we work with our customers. And in a similar manner, artificial intelligence is likely to be leveraged by all of those industries in the future to make them more efficient than ever before. In fact, in a few years' time, customers will expect AI features in their next project to keep up with their competitors. So now is a perfect time to upskill in this area. Okay, so if you're not yet using client-side AI, I want to illustrate how fast this is growing, as we just mentioned, and why you should take a look before you're left behind. Now, I've only got statistics for Google's web AI libraries, so worldwide usage is probably higher, but in the last 2 years alone, we averaged 600 million downloads per year of TensorFlow.js and MediaPipe web-based models and libraries, bringing us over 1.2 billion downloads in that time, and we're on track to continue growing in usage. But why should you care about Web AI? Surely you can do all of this stuff in the cloud, right? Well, you can get some superpowers that are just not possible with a cloud alternative. Now, I know everyone watching today comes from different industries, so think about how any of these could apply to yours as we go through them. First up is privacy, as no data from things like the camera, microphone, or even text need to be sent to some remote AI model on a server, which protects the user's personal data. A great example of this is shown here by Include Health, who use browser-based pose estimation models to perform remote physiotherapy without sending any imagery to the cloud. Instead, only the resulting range of motion and statistics from the session are sent, allowing the patient to perform the checkup from the comfort of their own home while also protecting their privacy. You've also got the ability to run offline on the device itself, so you can even perform tasks in areas of low or no connectivity after the page load. Now, you might be wondering, why would a web app need to work offline? Well, in this great example by Hugo Zanini, he performs product placement verification using a web app in supermarkets for a retail customer that he was working with. And we all know how bad data connections are in supermarkets, being large metal structures. He leveraged TensorFlow.js to run a custom object detection model right in the browser that can work entirely offline and then syncs data back when a connection is available later on. Now, you can imagine applying similar techniques to retail analytics solutions to monitor what objects are most interacted with, or maybe even within digital kiosks in the aisles of these supermarkets to understand how busy an area is at different times of the day. Or what about healthcare solutions in pharmacies to count pills more efficiently for prescriptions, and much, much more, all working offline to conform with regulations? Next is low latency, which can enable you to run many models in real time, as you don't have to wait for the data to be sent to the cloud and back again, which might be significant if you're on a mobile phone data connection, for example. As such, many of our models, like these ones from MediaPipe for body pose and segmentation, can run at over 120 frames per second on a mid-range laptop's graphics card, with great accuracy, as you can see on this slide. You've also got lower cost, as you don't need to hire and keep running expensive cloud-based graphics cards and processors, which means you can now run generative AI directly in the web browser, like this large language model on the left, without breaking the bank. And we're now seeing production-ready web apps benefit from significant cost savings too, like the example shown on the right for advanced video conferencing features, like background blurring in the browser. And even better, you can offer a frictionless experience for your end users, as no install is required to run a web page. Just go to a link and it just works. In fact, Adobe did exactly that here with Adobe Photoshop Web, enabling anyone, anywhere to use their favorite creative features on almost any device, even a Chromebook. And when it comes to the object selection tool shown on this slide, embracing client-side machine learning for this feature can provide Adobe's users with a better user experience by eliminating that cloud server latency, resulting in faster predictions and a more responsive user interface. And on that note, it means you can leverage the reach and scale of the web that has around 6 billion browser-enabled devices potentially capable of viewing your creation. Okay, so let's take video conferencing solutions as an example, but you can imagine this for other use cases that might also stream audio or video data, maybe for healthcare, security cameras, and beyond. Now, many of these services provide background blur or background replacement for privacy. So let's crunch some hypothetical numbers to see the value of using client-side AI here at scale. First, a webcam typically produces video at 30 frames per second. So assuming an average meeting is 30 minutes in length like today's talk, that equates to 54,000 frames per meeting that need to have their backgrounds blurred. So assuming 1 million meetings per day for a popular service, that equates to 54 billion segmentations every single day. Now, even if we assume an ultra-low cost of just 0.0001 cents per segmentation, that would still be $5.4 million per day, which is around $2 billion a year for server-side AI model inference costs. By performing the background blurring on the client side with web AI, that cost goes away. And don't forget, you can even port other advanced models to the browser, like noise cancellation, to further improve the meeting experience for your users, just like we do on Google Meet, while reducing costs even more by running all of these features on device. Or what about bringing large language models to the browser? In the example shown here, you can see how a user can generate an email to their friend for a given context and with certain requirements without any of the text being sent to the server. And even better, this runs really fast. The demo you see here is captured in real time. Now, at this point, if you're not from an AI background, you might be wondering how hard it is to use a large language model in the browser. Well, our MediaPipe LLM Task API allows you to choose from 4 popular models depending on your needs and use case, and can be used in just a few lines of JavaScript, so there's no need to be an AI expert. Let's take a look at this. First, you import the MediaPipe LLM Inference API as shown. Next, define where your large language model is hosted. You would have downloaded and hosted the model from the link in the prior slides. Now define a new asynchronous function that will actually load and use the model. Inside of this, you can specify your fileset URL that defines the MediaPipe runtime to use. This is using the default one that they provide and host, which is safe for you to use too. However, you could host this file yourself on your own server if you prefer. Now you can use the fileset URL from the prior line to initialize MediaPipe's fileset resolver to actually download and use the runtime for the generative AI task you're about to perform. Next, you load the model by calling llmtask.createFromModelPath, to which you pass the fileset and model URL that you defined above. Now, as the model is a large file, you must await for that to finish loading, after which it will return the loaded model, that you assign to a variable called LLM. Now you got the model loaded, you can use it to generate a response given some input text as shown. And here you store the result in a variable called answer. And with that, you can log the answer, display it on screen, or do something useful with it as you desire. And that's pretty much it. Now just call your function above to kick off a loading process and await for the results to be printed. Now, the key takeaway here is that while there are some very scary sounding variables like file set resolver, anyone watching this talk today can take and run this code and then build around it with your existing JavaScript knowledge for your own creative ideas, even if you're not an AI expert yet. So do start playing with these things today. Now, you can imagine turning something like this into a Chrome extension, whereby you could highlight any text on the web page, right-click, and convert it to a form suitable for social media, or maybe define some word you don't understand, all in just a few clicks for anything you come across, instead of needing to go to a third-party website to do so. I did that right here in this demo that I made in just a few hours on the weekend, entirely in JavaScript, client-side in the browser. There are just so many ideas waiting to be created here. In fact, people are already using these models to do more advanced things, like talking to your PDF documents to ask questions about its contents, without having to read it all yourself, as shown in this demo by Nico Martin. Now, this is a great time saver and a really neat use case of large language models when combined with surrounding RAG techniques. In this case, to extract the sentences from the PDF that matter and then use them as the context for the LLM to answer some given question, all working locally in the browser on your own device. Notice here how it even shows you the sentences it generated its answer from, so you can reference the actual human written knowledge, which might be useful to ensure no data was hallucinated in the answer. Or what if videos could watch themselves for you to extract useful frames all by themselves? I made this demo in just one day using Transformers.js, whereby I'm able to enter a sentence for what I want to look out for, such as my name in any video frame or an image of a guy standing on a plane, which is one of my hobbies when I'm not nerding out on web AI. And sure enough, it finds those frames for me, as you can see along the bottom. So from Chrome extensions that supercharge your productivity to features within a web app itself, we're at the start of a new era that can really enhance your web experience. And the time is now to start exploring those ideas. In fact, right now, generative AI in the browser is in its early stages. But as hardware continues to evolve with more RAM available to both CPU and GPU, we shall continue to see models ported to run in browser on your device, enabling businesses to reimagine what you can actually do on a web page, especially for industry or task-specific situations. In fact, we could see smaller large language models in the 2 to 8 billion parameter range be tuned for a specific purpose and run on consumer hardware. Right now, one could envision a hybrid approach, whereby if a client machine is powerful enough, you download and run the model there, only falling back to the cloud AI in times when the device is not able to run the model, which might be true for older devices. With time, though, more and more compute will be performed on device, so your return of investment should get better as time goes by, saving you money when implementing an approach like this. And on that note, we're working on a new website providing guidance for web developers choosing to use AI in JavaScript. With this site, we aim to help you understand key AI concepts so you can discover opportunities to use popular models to be more productive than ever. Bookmark the site shown on this slide, as we'll continue to publish more content here over the year. All right, now I want to head on over to see what the Web AI community have been up to. These are people just like you, but are already using machine learning in JavaScript in their products and services, just to give you a taste of what's possible.
Fundamentally, what we're trying to do is build tools to allow anybody to be their true self. There's a lot of people that feel uncomfortable on camera. Here's like a much more detailed side-by-side view of my face being captured alongside the face of the 3D character. And so what's happening is it's tracking individual facial blend shapes and then relaying them back into that Unreal Engine to render them.
I work as a radiologist, and the last 4 years I've been really interested in using artificial intelligence for segmentation. And this is a really nice thing with TensorFlow.js, I think, is that you can interact with the AI models. It doesn't have to do fully automatic predictions, but you can actually kind of guide the models to get the result that you want.
We're going to see an animatronic talking backpack that uses face mesh. And it was sort of a comedian in the wild experiment that respected social distancing. It does what you see. It puts all these tracking points on a face, and it can track it with and without glasses. It has an incredibly high frame rate, even in JavaScript and even in browser. So wouldn't it be great if you could use this technology to control animatronics?
So this is an example of how Cardinal Health is using RoboFlow to improve the backrooms of pharmacies. So they have a division of their company that works with pharmacists where one pharmacist can manage several locations remotely over a video stream. And so this runs in the browser on an iPad. And previously, it was just a video chat between the pharmacist and the technician. And then they used RoboFlow to add on a pill counting feature that helps the pharmacists be augmented by the computer vision model so that they don't have to count from scratch. They can use the model to estimate and then adjust up and down where the model has not gotten an exact count.
The video that I'd love to show here is a video piece that I constructed, which I call Mirror Exercise. And this is an AI-generated duet with myself. So what you're seeing here is in the figure in black is my real motion capture data from a couple data taking sessions in the studio. And in blue, you see a dancing accompaniment that is generated by the model. So in each case, the model is seeing a certain segment of my movements and is creating a slight variation on it in some sense.
It's a hand tracking engine called Yoha. And so what it does is it processes the video feed of your webcam and it detects the location of your hand in this video feed. And the goal of it is that it allows you to quickly sketch something roughly similar to how you would do it on a whiteboard.
Himo is a visual workflow engine that allows you to build very complex solutions in just minutes. And we do that through a drag and drop interface, which helps you define any kind of process without the need for coding. So this is the final version of the program. The video is a bit sped up, so things happen fast, but you can see that as water is taken out from the container, the graph reflects changes in the level of the liquid, which is what we wanted.
We wanted to go beyond machine and even beyond the clinic. And so that's really when we decided to expand our platform into computer vision and delivering care directly into patients' homes on their own devices. We're a medical device that we can run on any device, fully web-based. And you can see these patients doing different exercises, upper body, lower body, with real-time feedback, counting their reps. We track their range of motion. We gather all that and send it back to the clinician for review to help modify their home exercise plans accordingly.
Wow, some amazing demos right there. So no matter if you're recording motion capture data to transform your users into different personas to make an experience more fun, to the latest in generative AI, we can even run diffusion models in a web browser at incredible speeds with new browser technologies like WebGPU that are now enabled by default in Chrome. Things are about to get really exciting with regards to what we can expect from a web app of the future. So what types of AI models can you even run in the browser? Clearly not everyone here is working at video conferencing and Gen AI companies. Well, there are thousands of models out there, many of which can be used in just a few lines of JavaScript, and new models are coming out every single month. Now, I can't cover all of them in this short talk, but let's go through a few popular ones and think how we can apply any of these to customers that you work with. First up, we've got object recognition. This allows you to understand where in the image the object is located and also how many exist, which is much more powerful than image recognition alone. That would only tell you something exists, but not where or how many. You could use a model like this to create a pet camera that could notify you when your dog's been naughty eating the treats when you're away from home. I made this example application in about 1 day using off-the-shelf models that are capable of recognizing 90 common objects in the house, like bowls and dogs. And as you can see, it works pretty well. The dog in this video is caught red-handed as he tries to inspect the bowl of food, which you can then send an alert to do whatever you wish once you know this has occurred. And all of this is done without having to stream real-time video to a server 24/7. Instead, you just send the clip when the dog intersects with the bowl in that moment. Or what about text toxicity detection? Here you can pass a sentence to the model and classify if it's toxic or not, and even figure out what kind of toxic it might be, maybe an insult or a threat, for example. Something like this could be used to pre-filter comments in a web chat or commenting system on your website, automatically holding potentially toxic ones for further moderation. We can even extract 3D data from a 2D image with this selfie depth estimation model. You can pass it a portrait image of a person, and it will predict how far away each pixel is in the image, allowing you to understand the 3D makeup of the face and body. Now, if you can do that, you can do some really cool things like image relighting. Here, I can cast the light rays around my body for a more realistic effect than was possible before, which could be great for augmented reality or lighting effects on images. Next, we've got the face mesh model that's just 3 megabytes in size and can recognize 468 landmarks on the human face. And as you can see, it's running at well over 130 frames per second on my laptop. And we're seeing companies like Modiface, who's part of L'Oreal, use this technology in production web apps. The thing to note here is the lady on the right-hand side is not wearing any lipstick. Instead, they're using our face mesh model combined with WebGL shaders to color in her lips in real time based on the color swatch she's chosen at the bottom of the app. Really amazing stuff. We've also got models that can track your hands in both 2D and 3D at over 120 frames per second, again on a mid-range laptop with a dedicated graphics card. A model like this could be used for gesture recognition or even touchless interfaces for human-computer interaction. And with a bit of extra training, you can even do simple sign language interpretation. Pretty handy. Now, continuing on the human body theme, you can also detect 2D or estimated 3D pose for 33 key points at over 150 frames per second on a machine with a dedicated graphics card. This model has 3 forms, a light, full, and heavy version, which allows you to select a trade-off between accuracy or speed. Or building on this, what about full body segmentation? With a model like this, you can differentiate the human body from the background of the scene. And if you can do that, you can blur the body for privacy like we do in Street View, or you can apply effects to the background for a stylistic image. There's also a specialized version of this segmentation model that focuses on the upper body, as you see here, and this is better suited for typical video call situations. Okay, so you got all these AI models that make you feel like a superhero, but how can that help you? Well, by selecting the right models for the right situation, you can then provide your customers with superpowers themselves when you apply those models to their industries. In fact, at Google, we often need to explore what models to use for a given task. So we've created a system called Visual Blocks to do that in an efficient way. It's a framework I worked on with my team that allows you to go from an AI-powered idea to a working prototype faster than ever, built around JavaScript web components, so it's super easy to extend by anyone who knows JavaScript. And even better, once you make a building block to do a thing, you can chain them together with other powerful building blocks to bring your idea to life without getting lost in the code. And it's not just us using this. The examples on this slide were actually contributed by Hugging Face, who've been adding new client-side AI models via Transformers.js. And these are now available to explore using visual blocks in just a few clicks, which is great if you're new to the space. You can try them for yourself at the link shown. Just click their names to launch and use immediately. And here you can see a glimpse of the future, whereby a research team at Google used a large language model to create a visual blocks pipeline for me to solve some problem I had, like creating an augmented reality effect, just by explaining what I want in plain English and have it make the start of a prototype for me within visual blocks. Really incredible stuff. Now then, I'd just like to end by saying there's very few opportunities in one's life to be at the beginning of a new era like this. I, for one, remember when the internet came out for the first time. Yes, I am that old. And Web AI has the same feels as that, only magnified 100x. I personally believe that in the future, we as web developers will build AI-compatible websites, whereby you have the option to just talk to them naturally via text or voice to perform any of the tasks they support. and delegate that to an AI agent, maybe via an exposed AI.json file for the domain that the LMs can understand, instead of us manually figuring out some arbitrary workflow or user experience. And sites that are not AI compatible might be out of fashion pretty fast, just like when we moved to having mobile versions of our web pages as smartphones grew in popularity. Now, I hope in this talk I've been able to provide you a tiny glimpse into the future and why you should start investigating web AI today, because everyone watching here today has a chance of a lifetime to shape the future of this fast-growing space. And I hope that all of you will join me on this adventure. So, do tag me in anything you make, or if you've got any suggestions for any of the technologies I mentioned in this talk. You can also connect with me on social media using the links on this slide. And do remember to use the WebAI hashtag if you make anything worth sharing. Thank you,